Welcome to the Mipar tutorial on memory steps. Memory steps are an easy way and a powerful way in a recipe to bring back previous states of the recipe to the forefront. Since the recipe is a top-down linear flow, you need to have the ability to recall various past stages of the recipe in order to have that recipe architecture be as flexible and versatile as it is. So in this tutorial, I'm going to show a couple of use cases for memory steps and explain the logic behind them. So as usual, we'll start in the image processor. And a common case of needing memory steps, I mean, most recipes of any kind will have at least a few memory steps, but a pretty common case is when you have an area of interest that is not the same as the entire image frame. We can end up needing to use a few different segmentation steps to capture both the area of interest and the features separately, and then combine both to just keep the features inside of the area of interest. So here is a example of that, where, for instance, you might go after these vessels, and I won't spend too much time on that because this is just a demo to illustrate keeping features inside of an AOI. But let's say that you went with a line highlighting function, something like this, which aims to brighten up the vessels inside, and then you wanted to do a threshold on anything that is bright. So we might choose something like this. But now we have the vessels captured, but we also have all of this extraneous selection that is clearly outside of the area of interest. And there's no need to keep that because we can easily just exclude any of this because it sits in a very dark part of the image. So let's say that you didn't think ahead to set memory steps. That's okay, you can set them at any time. What we'll do now is go back to the original so that we can threshold just on the obvious AOI. And we can use an auto threshold for that. So an auto threshold here clearly captures everything that's inside this circle only. We'll switch to binary view to see. So we have all the features and some noise up here, and we have just the AOI down here. So if we want to combine those two and say only keep features in this image that are inside of features in this image, all we need to do is set one up as the companion and the other up as we don't need to set the other one up. It just needs to be the current image when you do the combine operation. So as we've mentioned in other tutorials, any step that has an asterisk next to it means that it requires a companion image to be set in the recipe, usually a black and white companion image. The companion image can be thought of as the other image. What is the other image that I'm going to combine whatever image I'm looking at with? And because there is no companion image set, there's no companion image step in the recipe that's done the setting, then all of these asterisk operations are grayed out. So what we want to do is basically fuse this image with this image. So no matter what image I'm looking at, I'm just going to click on this image here and go up to memory and say set it as the companion. Now that adds a set companion step. The result of that step is the same as 2 because all this step 3 has done is take what was in step 2 and put it in the companion slot. And now when we're back down here, if we go to memory, or math rather, we see all of these are now lit up. And if we say feature intersection, that's going to take all of the features in the image that you're looking at when you click this step, feature intersection, and the latest companion image above it, which is step 3, and it's going to fuse them together. And now we have taken our features, set them in companion, gone back, selected our AOI, combined them, and we just have the features inside of the AOI. Now there can be other use cases for memory images. Let's stay on this same example, and let's say that we wanted to segment the vessels with a different approach. We wanted to run an adaptive threshold, which will locally detect pixels that are darker relative to their surroundings, their immediate surroundings, but we only wanted to perform that thresholding inside of this AOI. In other words, we didn't want to consider any of the black when running that adaptive threshold algorithm. Because the adaptive threshold has a mask step, you can set any binary, any black and white, any selection image, memory image that has been set previous to this step, and right now there aren't any. You'll see if we did an adaptive threshold here with some sort of setting, just going after the fine dark features, then we end up not only selecting all this noise out here outside the AOI, but you see vessels that are very close to the perimeter don't get selected because their windows, these pixels window, which is 30 pixels, that is being considered actually includes some of this very dark intensity. So these pixels right here are not seen as dark relative to their average because their average now includes some of this pure black. So we really need to just have Mipar ignore anything that is outside of this area of interest when running the adaptive threshold. It's not enough to just mask out afterwards, because having this dark in place actually affects the segmentation in what we would ultimately mask. So what we can do is first do a basic threshold again just to select our AOI, and then we can set that up as any memory image we want. It can be the companion, it can be 1 through 6, it just needs to be in some slot, and it needs to be a black and white step. So I'll set it in 1, and then I'll go back to the original, and now when I do my adaptive threshold step, you see we can choose memory image 1 as the mask. So let me go back to the same rough selection up here, and if we now choose the memory image 1 as the mask, that is now only going to have the adaptive threshold consider the pixels that are inside of features that are in memory image 1. You can see when we do that now, we still get a few pixels on the outside. These are just slightly darker right along the edge, but we certainly get more of the perimeter touching or approaching vessels than we did before with no mask. And we've certainly cleaned up the noise outside of our area of interest. Now, one of many powerful features in Mipar is the ability to, as we know, insert or edit steps at any point in the recipe and have the change propagate through. So you might at this point say, well, I want to erode my area of interest selection before I use it in the adaptive threshold. So what we can do is set an erosion step after the threshold before the memory image number 1 gets set, so that now memory image number 1 will be the eroded version of the threshold. And when that eroded version is used as the mask in this step, this perimeter noise should disappear. So all I'm going to do is stay looking at this step, click up here, come down to erode uniform. Because I have the last step selected, it asks me, do you want to put this above or below? I'll say below, and I'm just going to give it 1 click of an erosion. So that has just shrunk our selection by 1 pixel. And if I hit accept now, then we're taken care of. Maybe I should bump it up to 2. And now that perimeter noise is gone without having to erase back to any previous step. So that is a case of using a memory step to feed into another step as a mask. And what we can look at next is when you may want to restore a previous grayscale manipulation of an image for multiple segmentation steps. So let's say we had an image where we had to recall its a grayscale manipulation later on. Let's go and take this asphalt example here. And suppose we just needed to do a crop operation on it. For whatever reason, say you had a scale bar down here, or you only wanted to crop a certain area away. Now again, if you're going to batch apply this, make sure that you're batch applying it to images that are all the same size so that this crop area makes sense image to image. If your images are going to vary in size, then it's advisable to pre-crop the images prior to running the recipe. But let's say you had a crop image in there, and then we did some sort of basic threshold here to find all of the larger features. So we did something like this, and we had a cleanup operation here. And then we shrunk everything down a bit, and we rejected small features. That one there is 388 pixels, so let's put a bar of 400, and then dilate this all back up, and then fill all of our holes. Maybe not all holes, because that will include some of these edge features down here. So holes that are this or bigger. Let's say 150 pixels, white features. So there we had, up that a bit. There we had a sequence of steps that found the larger features, and now we wanted to go back to the starting point and do some other steps to find the finer features. We wouldn't want to just call original, because original is now the uncropped version of the image. We need to recall the cropped version. To do that, we just need to have this crop image set as a memory step, or in a memory slot is another way you can think of it, sort of like on an older calculator where you have multiple memory slots that you can store variables in and call them later. That's how the memory slots in Mipar work. So let's just click on that step and say set as memory 1, put that step below. Otherwise, if you hit above, you would be setting the original image as memory 1. And now when we're at the bottom, we can call memory 1. This step is active because prior to this point in the recipe, there is a memory number 1 that has been set. If there was no memory 1, you wouldn't be able to call a memory 1. So now we've called the crop step down here, and now we can do whatever we wish to go about the thresholding of the fine features. Let's just suppose we did something like this. I won't do any cleaning up or separating on the fine features because this tutorial is just to indicate or illustrate the use of the memory steps, not so much this particular segmentation problem. But what we can finish with is a nice tying it all together of multiple applications of memory steps, where we now want to subtract out the larger features that we had found from this image to leave us with just the fine features. So back at this point in the recipe is where we have the large features found, actually this point where we have the holes filled in. And now we want to subtract these features from this image. So again, I just need to set the features that we want to subtract as the companion image. So let's click on that step and set it as companion. And now down at this step here, if we do a memory feature or math feature minus, we will take whatever is in the companion, the latest companion relative to this step. We'll take whatever is in the companion and subtract those features from the image that you're on when you run the feature minus. So math feature minus, and they're subtracted away. Now, in some cases, you may want to dilate the features to subtract, say by 1 or 2 pixels, just to make sure that they completely subtract away all pixels that belong to them from this image here. So you may want to, again, prior to setting as companion, dilate a bit. So just put a uniform dilation step right above companion, do a couple of pixels. And now that dilation step becomes the companion, which gets subtracted from this step to give us this step. And there we go. You could finish off with setting as layers if you'd like. You certainly don't have to set the dilated result as layers. We would just set the accurate selection as the large layer. So we could set this as a layer and call it large. And then we could set this step down here as a layer and call it small. And now there is a combined colorization of what we call the large particles and the small particles, using 2 different implementations of memory steps. This first implementation certainly could have been to set and recall a filtered version of the image. Say you ran a noise filter on this image, and then you did some steps, and then you wanted to recall the noise filtered image and do some more steps. You would use this same structure where you'd set the filtered image as memory 1, and then you'd call memory 1 later on. You don't have to redo that noise filter step later on. So it allows complete flexibility and nonlinear thought patterns to take place in a linear set of operations like a recipe. So that concludes this tutorial on memory steps. As always, contact us with custom recipe or custom training needs. Thank you very much for watching, and we'll see you next time.